Cramer's rule is a method of solving system of linear equations that uses the concept of determinant. Let's start with systems of two linear equations. That is, we have two variables x and y. The rule is if the determinant of the matrix A, B, C, D, that is the coefficient matrix of this system, if the determinant of that matrix is not 0, then the system has a unique solution given by this. The denominator of both x and y is the determinant of the coefficient matrix of the system. For the numerator of x, replace the column 1 of the coefficient matrix by the right-hand side of the system and get the determinant. Similarly, for the numerator of y, replace the column 2 of the coefficient matrix by the right-hand side of the system and then get the determinant. As an example, let us solve this system. First, let's get the coefficient matrix. The coefficient matrix is negative 2, 3, 2, and negative 5. Then let us solve for its determinant. This is a 2 by 2 matrix. So first, let's get the product of the entries on the main diagonal. Negative 2 times negative 5, that is 10, minus the product of the entries on the off diagonal 2 and 3, that is 6, minus 6. We have 10 minus 6, that is 4. This is not equal to 0, therefore we can use Cramer's rule. To solve for the numerator of x, we replace the column 1 of the coefficient matrix by the right-hand side, so that is 0, 1. And then let us get the determinant. We have 0, product of 0 and negative 5, minus 3, the product of 1 and 3. So we have negative 3. For the numerator of y, we replace the column 2 of the coefficient matrix by 0, 1. And then let's get the determinant. We have negative 2 times 1 minus 2 times 0. So we have negative 2 minus 0. Therefore, we have negative 2. And thus, x is equal to negative 3/4. This is the numerator divided by the determinant of the coefficient matrix. We have 4. And for y, the numerator is negative 2 divided by 4, or simply negative 1/2. This rule of solving linear systems is analogous for if we now have several equations or variables. Let's try it with 3 equations. We consider a linear system of 3 equations and 3 variables, x, y, and z. If the determinant of the coefficient matrix is not 0, then the system has a unique solution given by the following. The denominator of x, y, and z is the determinant of the coefficient matrix. For the numerator of x, to get the numerator of x, we replace the column 1 of the coefficient matrix by b1, b2, and b3. For the numerator of y, we replace the column 2, and similarly for the numerator of z, we replace the last column. Let's try the example. We solve this system of 3 equations. The first thing that we need to do is to check if the coefficient matrix has determinant that is not equal to 0. This is our coefficient matrix. 1, 2, 3, 2, negative 3, 2, and 3, positive 1, negative 1. The determinant, this is a 3 by 3 matrix. So first, let us get the product of all the entries on the mean diagonal. 1 times negative 3 times negative 1, that is 3, times 2 times 2 times 3, that is 12, 3 times 2 times 1, minus, now let's go to the off diagonal, 3 times negative 3 times 3, then go to the right, 1, 2 times 1, times negative plus negative 1 times 2 times 2, that is negative 4. And if you simplify, we have here 3 plus 12 plus 6, that is 21, minus negative 27 plus 2, so we have negative 25, minus 4, we have negative 29. So 21 minus negative 29, that is 50. The determinant of the coefficient matrix is 50. That is, it is not equal to 0, so we can use the Cramer's rule. For the numerator of x, what we do is we replace the coefficient matrix, well, we replace the column 1 of the coefficient matrix by the coefficients here on the right hand side of the matrix, 6, 14, and negative 2. And then let us get the determinant. So we have here 18 minus 8 plus 42 minus 18 plus 12 minus 28. And if we simplify this, we get 50. This is the numerator over this denominator. So we have x is equal to 1. Do the same with the numerator for y. Replace the second column of the coefficient matrix by 6, 14, and negative 2. If you do that and get the determinant, you will obtain negative 100. And so you get y is equal to negative 2. And lastly, for the numerator of z, replace the third column of the coefficient matrix by 6, 14, negative 2. Then get the determinant. You will obtain 150. This is the numerator over 50. We get z is equal to 3. As an exercise, solve the following system using Cramer's rule.